Coding is fundamental to literacy in the future. Following the words of popular American software engineer and business executive at Apple Inc., Craig Federighi, I wish you all a very good evening as you join the awareness session of IEEE Extreme 17.0 programming competition conducted by IEEE Student Branch of University of Sri Jayawardenepura. We warmly welcome all the coding enthusiasts who are ready to take up the global challenge and win the world through their programming skills to today's session. So, to start off and mark the initiation of today's proceedings, I cordially invite Sandaru Senitha, the organizing committee member of IEEE Extreme 17.0 programming competition, to deliver the welcome speech.
Thank you, Saini. Ladies and gentlemen, a warm and enthusiastic welcome to all of you to this online awareness session for IEEE Extreme. It's a pleasure to have you join us today. I am Sandaru, and I have the privilege of welcoming you to this exciting event. To make our session even more enriching, we are honored to have a distinguished guest with us today. Mr. Pasindu Wijesena, a true luminary in the world of coding and innovation, is here to share his insights and experiences. His presence elevates our gathering, and we eagerly look forward to his words of wisdom. And I also welcome the IEEE Student Branch USJ Executive Board. They are the driving force behind the promotion of technology and innovation within our community. So, let's make the most of our time together. Engage actively, ask questions, and prepare to embark on this thrilling coding adventure. Without further ado, let's proceed with our program. Remember that Extreme isn't just about winning. It's about personal growth, teamwork, and embracing the joy of coding. Thank you all for gracing us with your presence. Let's dive into the world of IEEE Extreme. Thank you.
Thank you very much, Sandaru. Technology has already covered many aspects of our society, and it's our pleasure to invite a remarkable individual who constantly moves forward with technology as our special guest today. I cordially invite Mr. Pasindu Wijesena, co-founder of AI Teams, to share his IEEE Extreme experiences for inspiring insights at the intersection of technology and innovation.
Thank you, Sayoni. All right. So I hope all of you are having a great day. Today is going to be, I believe, the very first session of the awareness session series. And so today specifically, we are going to touch in an intro into competitive programming and talk a little bit about the IEEE Extreme competition, the competitive programming competition. And so you guys are going to join the session with me today. Thank you very much for joining in. So to give a bit of an introduction, I'm Pasindu, and I've been involved with competitive programming since 2012 when I was schooling. And so my last competition was in 2021. It was IEEE Extreme 15 competition. And after that, I haven't competed, but I'm involved in the problem creation process for competitive programming competitions, specifically with the National Informatics Olympiad program. So I believe that I'd be able to share a bit of insights and tips and tricks that you guys would need to help compete at the IEEE Extreme competition. All right, so let's get started. Right. So this session is going to consist of a lot of questions, and you guys have to interact with me. And so we are starting off with the question. So the first question: what is the number that comes next in this series? So the presentation has been shared with you guys, but I hope that you won't take a look at it yet. So it's for you guys to take a look afterward at the end of the session. So right now I want you guys to guess, not actually guess, try to find the next number that should come in the series. So you can either unmute yourselves and tell the number, or you can write in the messages section in a way that everyone can see. So I'll give a minute. Sorry. All right, so we have 3 answers. Okay, we have a bunch coming in. Right, so we have an audience of 68 people. So I want the rest of you guys also to speak up or just comment your ideas. So far everyone says 21. Okay, and we have the name for the series as well, Fibonacci 21. Right, so I tried to say 19, but no, it's 21. And this is, of course, the Fibonacci series. Right, so I want so now what I want you guys to see think is, how did you compute this number? So you first told me the answer. Now I want you guys to say, how did you compute it? How do you how do you give how do you compute the nth term? What's the way of computing? Can write it down. What do you guys think? Can we have some formula or some standard structure that would allow us to compute the nth Fibonacci? So showing it here, we have an answer. We can get the next number by adding the previous 2 numbers, of course. Nice. Right, so how we do it is, like if you want to compute the term n Tn, then we can find it by the summation of Tn minus 1 and Tn minus 2. And so we also have some base conditions. So here in this series, we have defined that T1 and T2 are equal to 1, right? And then after that, we can compute whatever the nth term using the previous 2 terms. Right, now I want you guys to find out the 21st Fibonacci number. Now, before you Google or use your calculators, this is a thinking exercise. So what I want you guys to do is to think about how you can solve this problem. Assume that you only have a paper and a pencil. And if that was the case, how can we compute the 21st Fibonacci number? And if any of you guys compute, you can write down the answer as well. Guys, I need ideas. How can we compute the 21st Fibonacci number? So previously we were given with the list of numbers, and right now let's say that we have the base 2 numbers, 1 and 1, and we know that the recursive definition of the function. And how can we go about finding the 21st Fibonacci number? And so here's how we can do it. We need to compute the previous 20 numbers, right? So we had a recursive definition, and so to go about finding the 21st Fibonacci number, what we had to do is we'll have to compute the first 20 numbers, and so iteratively we can find the next one, and after finding the 20th one, we can find the 21st. Right. So using this pattern, we can convert what we just did into a sort of an algorithm, right? So here what I have written is how we can compute the 21st Fibonacci number, assuming that we have this notion of memory, sort of thing when you want to represent an algorithm in some pseudocode term. So we have this T1 and T2. These two are variables that have been initialized to 1, right? And then we are going to repeat this process 19 times, right? So the first step is we have this Tx variable, which is assigned the summation of T1 and T2. And then we assign the value of T2 to T1, and then the value of Tx to T2, right? So after you repeat 19 times, a variable here is going to, like Tx or T1 or T2, is going to end up with the 21st Fibonacci number. So now I want you guys to think and tell me which variable is going to contain the 21st Fibonacci number at the end of this iteration. So let's say we execute the first one, the second one, and then we come into this loop for 19 times. And when we are at this point, which variable is going to contain the 21st Fibonacci number? I'm going to wait till you guys come in. All right, we have one answer. So it's actually not a single variable. He's saying that T2 and Tx both are going to contain the 21st Fibonacci number. Do we have any other answers? Right, I'm going to wait till a couple more people come in. Guys, I need answers. මොකද හිතන්නේ T1 ද T2 ද Tx ගාලා තියෙන්නේ? ඔයාලට මොන හරි තේරෙන්නේ නැති පොයින්ට් එකක් තියෙනවා නම් කමෙන්ට්ස් මේ මැසේජස් වල දාන්න, නැත්නම් අන්මියුට් කරලා අහන්න. So guys, if there's anything that you don't understand, you can just unmute and ask or type in the messages. All right, we have one answer. It is T2. T2. Okay, we have a couple of T2s. Nice. Right. For the guys answer. So let's go through this like instead of finding the 21st Fibonacci number, let's try to see the 4th Fibonacci number. Okay, how can we compute it? Give me a second. Share my screen. Right. So we have, this is the algorithm that we have. T1, 1, T2, 1, and then we repeat. So here we add 19 times. Right. So this is the algorithm that we have. So I'm going to change this 19 to a smaller one because to be easier for us to walk through. හරි මම මෙතන මේ 19 තියෙන එක පොඩි එකකට ගන්නවා. අපි හිතමු අපිට 5th Fibonacci number එක හොයන්න ඕනේ කියලා. එතකොට මෙතනට එන්න ඕනේ මොකක්ද value එක? So assume that we need to find the 5th Fibonacci number. Then how many times should we repeat? Here we have 3. I'm going to plug in 3. හරි. අපි දැන් step by step යමු. මේක execution එකේ. Start with this. T1 is 1, T2 is 1. Okay. We get into this loop section now. And we're going to execute this step. So at the end of once we execute this line for the first time, Tx is going to contain what's the value? So Tx is equal to T1 plus T2, which is 1 plus 1, and it is going to be 2. And then we go to the next line, this one. So T1, we are assigning the value of T2, which is 1. And then for T2, we assign the value of Tx. So the value of Tx is 2, right? So assign 2 over here. And now we've executed down to this point, which is the end of the first iteration of this loop, right? හරි. එතකොට මේ තුන් පාරක් iterate කරන එකේ first iteration එක ඉවර වෙනකොට Tx ගේ T2 ගේ තියෙනවා දෙක කියලා store වෙලා T1 ගේ තියෙනවා එක කියලා. එතකොට මේ ඉවරනට වෙලා තියෙන්නේ අපි බැලුවොත් එහෙනම් මේ Tx කියන එකනට අපි මුලින්ම compute කරා T3 කියන term එක. හරි. T3 කියන එක නම් මෙයාට මුලින්ම assign කරා. ඊට පස්සේ අපි යනවා shift operation එක. shift operation එක කියලා කියන්නේ දැන් T1 තියෙනවා, T2 තියෙනවා, Tx කියලා compute කරගෙන ඉන්නවා. අපි compute කරලා තියෙන values shift කරනවා. ඒ කියන්නේ T2 ට store කරලා තියෙන එක T1 ට යවනවා, Tx store කරලා තියෙන T2 ට යවනවා. ඒක තමයි මෙතනදී කරලා තියෙන්නේ. හරිද? එතකොට මේ Tx ට compute වුණ value එකක්, මේ දෙන්නට value එකක් compute වුණා. අපේ iteration එක ඉවර වෙනකොට T1 ගේ T2 ගේ values එකක් shift වෙලා තියෙනවා. Right? 1 1 2. So T1 and T2 are pointing to these next two numbers now. Right. So then we are going to go with the second iteration. Right. And in the second iteration, we have Tx equals T1 plus T2, which is, now I'm going to wait for you guys to reply. So what should be the value of Tx now? Tx has to be the summation of these two. Guys, I want you guys to talk or comment. මෙතන උත්තර දුන්නා. මේ කියලා දෙන්නේ අර මුලින්ම තේරුන්නේ නැති කට්ටියට ආන්සර් කරන්න බැරි වුණ කට්ටියට. හරි. එතකොට මේ ඔයාලත් කතා කරන්න. මොන හරි ප්‍රශ්න තියෙනවා නම් අහන්න. Right. So if you guys have any questions, please ask. Right. In either Sinhala or English. So we're going to store 3 here. This is going to get removed. And in the next line, T1 is equals to T2, which is this one. So I have 2. And then T2 becomes Tx, which is 3. Right. So that was the end of the second iteration. And then we go to the third iteration, the last one. So in the last one, what happens is Tx is equal to T1 plus T2, these two, plus 3, which is 4. And then we come to the next line. T1 is assigned to this one, so 3 over here. And then T2 is getting assigned Tx, so this guy over here. Right. So now we are done iterating 3 times, and we have the final values. Hari, අපිට T මොනවාද Fibonacci of 5 නේ හොයන්න ඕනේ. fifth Fibonacci term එක හොයන්න ඕනේ. එතකොට අපේ result එක තියෙනවා තැන් දෙකක දැන්. ඉවර වුණාට පස්සේ Tx එකෙත් තියෙනවා T2 එකෙත් තියෙනවා. එතකොට අපිට answers වලින් මුලින්ම චමිදු කිව්වා T2 and Tx කියලා. මේකම දැන් 19 times ගියාට පස්සේ same pattern එක තමයි ඉස්සරහට දිගටම continue වෙන්නේ. හරිද? එතකොට මේ ලියලා තියෙන අග එකේ හැටියට 19 times repeat වුණාට පස්සේ Tx and T2 දෙන්න ගාවම තියෙනවා ඔය 21st Fibonacci number එක. හරි. So guys, do you have any questions? And like when I talk in Sinhala, is it difficult for you guys to understand? Is there anyone? All right, I'm going to assume that we are good. Right, so let's switch back to the presentation. Right, so what we just did here, now we are going to get an introduction to what is competitive programming, right? So in competitive programming, we are going to solve problems similar to the one we just solved, right? So we wrote an algorithm that computes the nth Fibonacci number, right? And so in this example, we just put a value for n, but in general, our algorithm can compute any nth Fibonacci number. So in competitive programming comparisons, what you have to do is you have to come up with creative algorithms that can solve these given problems and first, right? So competitive programming comparisons අපි solve කරා වගේම අපිට problems හම්බ වෙනවා. ඒ problem solve කරන්න අපි හදන්න ඕන algorithms. Computationally මේ compute කරලා answer එක ගන්න පුළුවන් වෙන algorithms හදලා ඒවා computer programs වලින් express කරන්න තියෙනවා. හරි. හැබැයි පොඩි catch එකක් තියෙනවා. මේ algorithms ලියනකොට ඒවා ඒ algorithms correct ඒවා attributes තුනක් තියෙනවා අපි ensure කරන්න ඕනේ. ඒවා correct වෙන්න ඕනේ. ඒවා fast වෙන්න ඕනේ. Fast enough කියලා තියෙනවා. ඒ වගේම ඒවා memory efficient වෙන්න ඕනේ. Right. So when we are writing these computer programs for competitive programming comparisons, our programs must satisfy 3 attributes, right? So the programs must be correct. The algorithm that we write should be correct. I'll go to the details of these 3 attributes later on, right? And they need to be fast enough, and they need to be memory efficient. And also we can insert an enough word here, right? So what is a correct algorithm? A correct algorithm in the sense of competitive programming for us is an algorithm that's capable of computing the correct answer within the given input range, right? එතකොට මේ correct algorithm එකක් කියලා කියන්නේ අපිට ප්‍රශ්නයක් දීලා තිබුණා. දැන් මෙතන ප්‍රශ්නයක් තියෙනවා compute the nth Fibonacci number. ඊට පස්සේ constraints ටිකක් specify කරලා තියෙනවා. n less than or equal greater than or equal to 1, less than or equal to 10 to the power 9. එතකොට මේ input range එකේ enter එකේ ඉඳන් 10 9 වෙනි බලය වෙනකන් ඕන value එකක් එන්න පුළුවන්. ඒ මොකක් ආවත් අපේ program එකෙන් හරි ඒ කියන්නේ nth Fibonacci number එක output කරන්න ඕනේ. එතකොට so a correct algorithm is that's capable of not just outputting the correct value for the sample test cases, right? So we've been given with a whole range of numbers in the constraint section, and our algorithm should be able to compute the correct answer for this whole range, right? So that's the correctness part. And in competitions, how people evaluate, like when you write a solution for a problem, you write a computer program and then you submit the source code, right? And once you do that, how your solution gets evaluated is by a set of test cases that the problem setters create, right? So those guys, the problem setters, the problem creators, when they create these problem statements, they also create a whole list of test cases that they are going to test your solution against, right? So in this example, we have this n to be between 1 and 10 to the power 9. And in the sample, like not the sample, in the evaluation test cases, there could be hundreds or thousands of test cases that run your program, and they try to evaluate whether your program is going to output the correct value, right? So, and in these test cases, there are going to be like edge cases, like what is the Fibonacci of 1, 2. So 1 and 2, those were the base cases that we had. And then it would have like, what is the Fibonacci of 10 to the power 9, 10 to the power 9 minus 1. So any number within this range, they are going to test, right? And so your program is going to get full marks only if you pass those test cases. And like you need to answer the correct, give the correct answer for all those test cases, right? හරි. මේ correct algorithm එකක් කියන එක කියන ඔයාලට මොනවා හරි ප්‍රශ්න තියෙනවද? අපි දැන් algorithm එකක් ලියනකොට competitive programming competition එකක මේ correct algorithm එකක් ලියන්න ඕනේ. ඔයාලා සමහර කට්ටිය try කරලා තියෙනවා නම් සමහර කට්ටියට notice වෙලා ඇති අර අපි solution එකක් ලියනවා. හැබැයි submit කරාට පස්සේ wrong answer කියලා එනවා. ඔය wrong answer කියලා දෙන්නේ අපි හදලා තියෙන algorithm එකෙන් solve වෙන්නේ මොනවා හරි මේ input එකේ subset එකකට විතරයි. ඒකට ඔයාලා මොකක් හරි answer එකක් කියලා හිතාගෙන හදලා තියෙන solution එකෙන් මේ මෙයාලා expect කරන range එකටම මේ හරි solution එක එන්නේ නැහැ. එතකොට මේ correct algorithm එකක් කියන්නේ region range එකටම හරි correct උත්තරේ එන algorithm එකකට. Okay. හරි. මෙතන මොනවා හරි ප්‍රශ්න තියෙනවද? Do you guys have any questions here? Right. So I'm going to assume that we don't have questions here. Let's move on. Okay. What is the modular thing in the bottom of the slide? Right. So there was a question. It's not shared with everyone. Vidusha Seniratna. Right. So this one actually, this is for you guys who who are specifically into the details. So this is something that you usually see in these competitive programming competitions, right? So this is specifically there to help you with the memory overflow issues. So the backstory is like, if you, let's say we write a program to compute the Fibonacci number, right? And so we are computing the 10 to the power 9th Fibonacci number. And the 10 to the power 9th Fibonacci number is going to be very huge. And in order to store that, we are going to need a non-standard data structure that can store the number if we were to store it, right? So because of that, many competitive programming competitions, they ask you to like only store the modular value, some modular value. So that's why I stated this over here. Vidusha මල්ලි වාට තේරුණාද මේ 10 to the power 9 කිය +7 ඒක දාලා තියෙන්නේ memory overflow data structures වල memory overflow වෙන එක නවත්තන්න. දැන් usually integer data type එක ගත්තොත් ඒක represent වෙන්නේ memory එකේ 4 bytes වලින්. ඒකට 4 bytes වලින් අපිට specify කරන්න පුළුවන් සෑහෙන පොඩි range එකක් integers වල. සාමාන්‍යයෙන් නිකන් 2 into 10 to the power 9 වගේ යනකොට මම හිතන්නේ overflow වෙනවා. එතකොට ඒ overflow හින්දා එන issues ඔයාලට tackle කරන්න දෙන්න ඕනේ නැති නිසා. ඒ කියන්නේ මේ ප්‍රශ්නේදී අපි question කරන්න හදන්නේ මේ Fibonacci number එක මොකක්ද කියලා හොයන්න අර memory structure එක මේ හරි එක පාවිච්චි කරන එක නෙවෙයි. ඒක හින්දා මේක දාලා තියෙන්නේ. හිතනවා තේරුණා කියලා. Nice. Okay. All right. We are going to move on to the next one. A fast enough algorithm. Right. So in competitive programming competitions, in addition to this input range, we are also given with a time limit, right? So like you have to find the 10 to the power 9th Fibonacci number, but you need to do it within 1 second. So that's something you are always going to see in these competitions and of course in IEEEXtreme as well. So when you are coming up with the algorithm, you need to like there are ways to evaluate like how long your algorithm would take to compute an answer. We're going to like talk a little bit about how you can compute that later on in a slide. But the point to take here is that your algorithms have to be like creative to be able to compute the answer within the given time constraints, right? So if your solution is not able to compute within those time constraints, you are going to get like in these comparisons, you are going to see a message like a time limit exceeded in your verdict if you are exceeding the time limit, right? So that's the second property. එතකොට මේ second property එක තමයි අපේ algorithm එක ඔයාලා creative algorithm එකක් හදන්න ඕනේ දීලා තියෙන time limit එකෙන් solution එකට යන්න. එතකොට මේ Fibonacci number compute කරන්න තියෙන එක within 1 second compute කරන්න ඕනේ. 10 to the power 9th Fibonacci number ගුණ. දැන් අපි කලින් බලපු algorithm එකේදී 10 to the power 9th Fibonacci number compute කරන්න නම් first 10 to the power 9 minus 1 Fibonacci numbers ඔක්කොම හොයන්න ඕනේ. ඒකත් හොයලා තමයි 10 to the power 9th එකට එන්න පුළුවන්. එතකොට ඒ algorithm එක 1 second වලින් execute කරන්න පුළුවන් නම් තමයි එතකොට මේ මෙතනදී ඔයාලට දීලා තියෙන problem එකේදී ඔයාලා ලියන solution එක හරි solution එකක් වෙන්නේ. නැත්නම් එහෙම ඒක time out වෙනවා. හරි? Right. Okay, do we have any questions on this one? We need to build a fast enough algorithm. Right, I think we are good. And the next one is the algorithm has to be memory efficient, right? And this is also like memory efficient as in you need to use less than the provided memory limit, right? You can use it doesn't mean that you have to like go absolutely minimal, but whatever the limit that has been given to you, you should not exceed that one, right? So in this one, this question, we have a new problem. So right now we have been given with a set of queries Q, and for each query Qi in Q, compute the Qith Fibonacci number. හරි දැන් මෙතන ටිකක් වෙනස් ප්‍රශ්නයක් තියෙන අපේ අර Qi nth Fibonacci number එක හොයන එකම තමයි. හැබැයි ඒක queries Q ගණනක් හම්බ වෙනවා. හරි. ඒතකොට අපිට constraints වල දීලා තියෙනවා the value of Q ඒක maximum size එක 10 to the power 5. ඒතකොට queries maximum හම්බ වෙන්න පුළුවන් 10 to the power 5. ඒ වගේම මේ Qi එන්න මෙතනට එන Qi එකට එන්න පුළුවන් maximum 1 and 10 to the power 9. හරිද? එතකොට මේ constraint එකට අමතරව තව දීලා තියෙනවා අපේ memory එකටත් constraint එකක් දීලා තියෙනවා. හරි. එතකොට දැන් අපි හදාගෙන algorithm එකෙන් solution එක compute කරන්න ඕන මේ memory limit එකත් exceed නොකර. Okay. Api, right, let's try to solve this problem now. Okay, we are going to solve this one. Right, I need you guys to think about ways that we can try to solve the problem. So let's take like 5 minutes, and then you can type the answers or you can unmute and talk about the answer. දැන් අපි මොකක් හරි මේකට approaches කතා කරමු කොහොමද solve කරන්න පුළුවන් කියලා. විනාඩි 5ක් කරගෙන හිතලා බලන්න මොකක්ද අපිට කරන්න පුළුවන් කියලා. ඔයාලා හිතන ගමන් මාත් පොඩ්ඩක් හඳලා ලෑස්ති වෙන්න discussion එකට අපිට. All right, so do we have any suggestions? How can we approach the problem? හරි අපේ Q queries දීලා තියෙනවා. හරි. Q queries දීලා තියෙනවා. ඒ Q queries වල එකකට අපි හොයන්න ඕන Fibonacci එක. ඔක තමයි question එක. ඊට පස්සේ අපි කතා කරා constraints දීලා තියෙනවා කියලා Q වල size එක 10 to the power 5. ඊට පස්සේ Qi ට දීලා තිබුණා 9. ඊළඟට memory එක දීලා තිබ්බා 128 MB. වගේම අපි තව assumption එකක් දාමු time එකට. I make a 5 seconds queue. So this is the question, right? So I have to like connect the detailed algorithm. Just talk about approaches to solve this one. හරි මේක solve කරන්න මම base approach එක කියන්නම්. මේක තමයි straight forward approach එක. අපි ගාව දැන් කලින් හදාගත්තනේ මේ Fibonacci compute කරන function එක. එයාට n කියලා දුන්නාට පස්සේ repeat කරනවා n-2 times. ඊට පස්සේ return කරනවා Fibonacci of n. So this is the algorithm that we previously created. Right? It's going to repeat n-2 times and then it's going to spit out the Fibonacci. And so what we can do is ඔක තමයි අපේ approach එක first approach එක. හරි. අපි මේ approach එක ටිකක් analyze කරලා බලමු මොනවද මේකේ තියෙන අවුල් කියලා. Right, what could be problems approach? Like, is this approach good? Is this approach not enough? In like, first thing is this, second one is this enough, third one very limitations. Right. Correctness second මොකද හිතන්නේ? Back. Another. Correctness second contact දෙන්න පුළුවන්ද? Correct කියලා. Okay, මේක incorrect කියලා කවුරු හරි arguments තියනවද? තියනවා නම් අපි ඒක කතා කරමු. මේ approach එක correct ඒක incorrect කියලා feel වෙන කට්ටිය කවුරු හරි ඉන්නවද? ඇයි correct කියලා කතා කරන්නේ? හරි මම හිතන්නේ incorrect කියලා argument එක නෑ. එතකොට හරි අපි so we assume that this them is correct and we can find anyone arguing against that one. So in terms of memory, what do you guys feel? So we didn't discuss any exact do you have any comments regarding our memory consumption program? So what would happen is like we have some array qi, so some array q which is going to hold the q into megabyte 4ක් වයි. So this one it's going to like it's just storing. We have 3 variables and this loop iterator 4. So it's not going to store a lot of things in memory. So in terms of memory also this is fine. And in terms of time, what do you guys feel? Okay, we have one answer. Use too much time and memory because when calculating highest fib number, other QIs are generated, therefore not efficient. Right. Okay. මෙතන මේ memory එක ගැන comment එක what do you guys feel, what do you feel about the comment I gave regarding memory? So this array it's only going to consume 0.4 megabytes because our size is Q, the size of Q is this, right? And we have 128 megabytes. So this is going to be fine. And then this part, within this function, we only store, like at any considered time, we have 4 variables stored in memory. And so this one would take another one, 5. So 1, 2, 3, 4, yeah, 4 variables. So that's going to consume 4 bytes into 4. So it's not going to affect this one. So while like when we are iterating through each iteration of this loop, we are not going to, like, the previously allocated memory values, we don't need them, right? They're going to get freed. We don't need to keep them. So we only consider about the current Fibonacci calculation. And for that one, we only needed 4 variables. So in terms of memory, memory that we are using, this is going to be fine. But in terms of time, it's not going to be very fine because, like, if you notice, we have 10 to the power 5 queries, and each query can go up to 10 to the power 9, right? So now assume that our input was 10 to the power 9, 10 to the power 9, 10 to the power 9. So like assume that Q had 10 to the power 9 this many times, right? So if that was the case, in each, like, we are going to call this fib n 10 to the power 5 times. Each time we are going to go this repetition 10 to the power 9 minus 2 times, right? So a single iteration is going to consume a considerable amount of time, and we are going to do compute that time, some t, into 10 to the power 5. So that's where the problem is in this algorithm. හරි. මේ approach එකේ අවුල click වුණාද? මොකද්ද මේ කතා කරපු එක? එතකොට මේ correctness එක ගැන ප්‍රශ්නයක් නැහැ. ඒක correct. memory එකේ ප්‍රශ්නයක් නැහැ. අපි analyze කරා. memory usage එකත් හොඳයි. හැබැයි time consumption එක ගත්තොත් එහෙම ඒකේ මේ fib n compute කරන එකේ loop එකක් තියෙනවා. ඒක යන්න පුළුවන් 10 to the power 9 times. ඒ වගේම ඒ loop එකත් අපි මේ function එක call කරනවා qi time, q times. හරිද? For each qi යනවනේ. එතකොට 10 to the power 9 into 10 to the power 5 යනවා steps මේ උත්තරේ ගන්න. එතකොට time එක side එකෙන් මේක මදි. හරි. Guys, did you understand what I tried to convey to you regarding the time that we are taking in this algorithm? Do we have any questions? Any follow-up questions? Right. I'm going to assume that we don't. And so what's a good way to then solve this problem? We need another approach. What do you guys think? How can we improve this? So we have a base solution now, right? But this solution is not enough. And in this solution, the key pain point was that we are computing we are wasting a lot of computations because, like, to compute a single value, we need to go through like the first one up until the qi Fibonacci value, right? So let's say like our q was equal to 1, 3, 10, 2, 5. So if this was our q, right, we are going to find q1. That means just this is going to go, we don't need this one actually, so just this one, and then 3, 10. After 10, we are computing 2. So when we were computing the value for 10, we already, like, while we were doing that, we already had the value of fib2, and same for 5. So one point that we might be able to optimize is by reducing these repeating elements, right? So when you compute the Fibonacci for a particular value, you don't have to compute it again, right? එතකොට මේ මෙතන පොඩි quality එකක් තියෙනවා. අපි same Fibonacci number එක ආයෙ compute කරනවා. කියන්නේ අර 10 Fibonacci එක හොයන්න කිව්වොත් එහෙම එකේ ඉඳන් 9ට තියෙන ඔක්කොම හොයන්න ඕනේ. ඊට පස්සේනේ 10th එකට යන්නේ. හැබැයි දැන් අපේ ඉන්පුට් එකේ මේ 10th හොයන 10th එක වගේ මේ මැද ඒවත් තියෙන්න පුළුවන්. එතකොට ඒ නිසා අපි unnecessary විදිහට මේ computation time use කරනවා. එතකොට මේක avoid කරලා යන්න පුළුවන් මොන හරි solution එකක් තියෙනවද? හිතලා බලන්න. මම විනාඩි 2ක් දෙන්නම්. හරි අපිට approach එකක් තියෙනවද? විදුෂ, හරිත, මොන්ටි, මෙතුලි. මොකද හිතන්නේ? ටයිප් කරන්න වෙන්න කතා කරන්න අන්මියුට් කරලා මේ approach එක ටිකක් දිග වෙන්න පුළුවන් ටයිප් කරන්න. guys nice, we have an approach. Can we sort and start doing from the smallest one while saving the number when proceeding to the next one? Great. Do we have any other approaches? I'm going to write that down. හරි දැන් මේ approach එකේ පොඩි වෙනස්කම් ටිකක් කරන්න තියෙනවා. අපි we are trying to use this sort this list, okay, and what we are going to in the ascending order, right? So when we ask to compute the values in the ascending order, what we can do is we can reuse the previously computed values to compute the next one. So let's say our queue is, say, sorted queue is equal to say 1, 2, 2, 5, right? So අපේ sorted queue එක sort කරාට පස්සේ 1 1 2 2 5 කියලා තිබුණොත් එහෙම අපිට කොහොමද මේ previous value එක reuse කරන්න පුළුවන් ඊළඟ එක compute කරනකොට? මෙතන අපේ මේ fibben function එක ටිකක් modify කරගන්න ඕන මේ values ටික global level එකට store කරලා අපි ගා last computed value එක මොකක්ද කියලා track තියාගෙන ඒකෙන් පුළුවන් මේ මෙන්න මෙතන මේ recompute කරන එක නවත්තන්න. So what we have to do is we need to keep track of need to first get these values out, right? And then we're going to know the last, let's say the last, and we're storing it as 2, right? So whenever we compute a value, we now try to update the queue last value, and then this needs to be changed. So this needs to be n-2 so what should be the value that we have to put here? So what we need to do now is to only go for the missing range. So let's say in the Fibonacci series, the first one is here 2, 3, 4, 5, 6, 7, and let's say we have computed this range and this 4, and then next we have to compute Fibonacci of 7. Then what we have to do is we need to compute this missing region, and then we can go about computing 7, right? So you need to update this repetition value to point to, like, you have to compute how many times you need to repeat now, right? So we need to go to three repetitions are going to get us into the target that we need. So something like n-q past, something similar to this, right? So that would we can plug something like that into this, and then what we will do is whenever we are asked to compute a value, we are going to look at the last computed point, right? From to compute some value over here, then we are only going to fill in this region, and after that we are going to find the required value. Right. මේ මෙතන ගත්ත approach එක තේරෙනවද approach එකේ? ඔයාලට ආව ප්‍රශ්න? Right. Vidusha, Mala, did you understand? Do you have any questions? And Harita, Mohanty. Guys, are we good? Shall we move ahead? Guys, I need an answer. You need a question or an okay to move ahead. Yes, exactly. So in this one, we need to use an efficient sorting algorithm. Yes, you are correct. This place. So in our previous situation, we were doing 10 to the power 9 into 10 to the power 5 operations, right? And so with this new revamped solution, we need to like this part is going to only go up until 10 to the power 9 operations, right? And so this guy we need to find a like efficient way to sort, and like the standard efficient sorting algorithms, they take around like 10 to the power log 5. So around this time is what they're going to take. Right. So now let's analyze the three attributes. The first one, the correctness. So like this algorithm, you might have to tweak these specific values and like make this function to work for the edge cases, right? But the approach that we are talking, it's a correct approach. And in terms of the memory usage, what do you think? We are storing the solutions for the, so in here we need to store the solutions for each of the QI elements, and that's going to consume 10 to the 5 in terms of memory. And in terms of time, we have optimized this one. So this value is far less than this one. So in terms of the time that we are going to use in this solution, it's way better. And in practice, if you are given with this problem, you'll have like the way to go would be something like this, this approach that we just discussed. But like here also you have to use like a special data structure called hash map. But we won't go to the details of that one here in this workshop. But in practice, like for this specific problem, the approach that we took is more or less the like optimal approach that we can do. Right. Do we have questions? I'm going to shift to the presentation, and if you have any questions, please do ask. Right. So how do we quantify this? How quantify this as in how do we quantify whether our algorithms are memory efficient, whether the algorithms are fast enough? How do we do that? There's a concept called the big O notation, right? So the big O notation is going to help you determine the time complexity of an algorithm, the memory complexity of an algorithm. So I want you guys to read, take a look at the big O notation, and specifically like this book, the link I have put here, it links to a book. You can go to the presentation and get the link. So this book explains the big O notation in a really good way, and it has a lot of resources that would help you to compete at IEEE-Extreme. So I recommend that you go and take a look at this one, right? And so to the next point, so what we went through to solve the previous problem was that we created an algorithm, like we curated a creative algorithm from our own like observations, right? And so people have been doing this for years and years, and as a result of that, we have a lot of standard algorithms and data structures that you can use to solve common problems, right? So like at IEEE Extreme or any other competitive programming competition, the solution that you have to come up, it would mostly fall under some standard like problem, and some standard problem pattern, or like it could be a combination of a different set of standard problem patterns. And then in order to tackle those things, you can use like standard algorithms and data structures. And now there are a lot of algorithms and data structures. So in order to be better at competitive programming, what you need to do is to like study these algorithms and data structures. So like when you see a problem, you'll be able to apply a similar thinking pattern and maybe use a similar data structure or a like slightly modified data structure to solve the problem. So this is very important because like creativeness is going to get us some distance, but these competitive programming competitions, they are time bounded, right? So you need to come up with a solution fast. So because of that, you need to learn these standard algorithms and data structures. So that would help you in the competition. And the resource to learn that, these ones, they are available in this book. So if you can go to the book, this is curating a really good set of data structures and algorithms that should allow you to probably be at the like very top competitors at IEEE Extreme internationally, and it's definitely going to help you get to the like top ranks in the Sri Lankan rankings, but of course in the international ranking as well. Okay, I'm going to move forward, and here's another resource. So this is for you guys who do not like reading, and so this guy is going like doing practice problems just like the ones that we did just now. He's doing different problems, so you can watch him doing like how he's approaching different problems. This guy called Ericto. So I recommend that you take a look at his channel, or like there are a lot of channels that came up recently. You can find something that resonates with you. And then the next thing is like there are a lot of data structures and algorithms that you can use to solve these problems. And so in order to be able to like apply a certain like algorithm or a data structure, you need to like practice. You need to have some practice solving similar problems. And for that, Codeforces and CS Academy are just two of the resources. And among these two, CS Academy is the platform where IEEE Extreme gets hosted. So in here, you'd be able to find like past questions of, I think, like around 5 or 6 previous IEEE Extreme competitions. So I recommend that you go register on the CS Academy and try out the previous IEEE Extreme competition problem, right? And I'm going to touch on this one quickly. It's a very unit theories, right? The data structures, rhythms, and then you do. Since IEEE Extreme is a team competition, you should absolutely value you can bring with a team people, so 3 people trying them. You need to like practice with your team, figure out what suits you the most, right? So whether it is parallelization or joining together or something in between, you need to find out like what are the weaknesses people like I mentioned that there are different algorithms and data structures, and like different problem types are also there. So there are graph problems, there are dynamic programming problems, divide and conquer problems, greedy problems. So some people are better at specific areas, right? And since you guys have a very limited amount of time, you guys can divide the areas that you want to look up and then practice in those areas. So that could be an approach, strategy, right? So you need to practice with your team. Prepare for the election is it is 24 hours long. So at the beginning you're going to be fine, but towards the very end of the competition you're going to be tired and sleepy. So make sure that you don't waste all your energy at the beginning, right? So take a standard pace, and like questions are going to get released like every hour or so. So at the beginning of the competition you are not going to see all the questions, right? So they're going to keep coming on and on every hour. So you need to have this like be able to go on this marathon, right? Have something to help you keep awake and get some sleep on the previous day. And another thing that you need to know specifically about IEEE Extreme is that like submitting a solution fast is not going to get you bonus points. All right. So you don't need to rush into solving specific problems as soon as they are released, right? You can try to solve the problems that are easiest for you first, and then like on the way you can like after some time has passed after this original problem was released, you can try the problem. And so with IEEE Extreme, they have a public scoreboard, so you can also see like what problems other people tackled, so that can actually give you an idea about like which problems should you tackle, which ones are easier, which ones are harder. That will help you decide. And then the next thing is you can use partial scores at IEEE Extreme. So we discussed that among the three attributes that your solution should satisfy, it needs to be correct, time efficient, and memory efficient. So since these problems are getting like your solutions are getting tested against test cases that these problem setters create, they like with IEEE Extreme, you don't have to pass all the test cases in order to score. So if you pass a single test case, it's going to get you a set of marks, right? So you can use this property towards the end of the competition to like go and collect small marks, right? That would help you to like optimize your rank within the sub ranks. And finally, the last one is don't stick to a single programming language, because at the competition there are going to be problems that could be solved with different languages faster or like in an easier manner, right? So the last thing is like it's good if your team is capable of solving problems under one or two languages, right? And you can use that to help solve different problems. And like these are the tips and tricks that I learned across my time competing at IEEE Extreme 4 times. And right now we are open for questions. Do we have any questions? Any follow-up questions? I'm going to wait 1 more minute. All right, then I think we are good. Sayuni?
Yes. Thank you very much, Mr. Pasindu, and it was an honor to have you with us today. And thank you for sharing those valuable thoughts with us. So after a couple of hours filled with important information about this competition, we are now going to move on to a fun-filled session. Mr. Sandaru Senikar, the organizing committee member of IEEE-Extreme 17.0 programming competition, is ready to take the stage to carry out this session. Mr. Sandaru, the stage is once again yours.
Hello, guys. So I feel like you got a lot of things from today's session. So to check your understanding, refresh what you've learned just now, we have organized a small quiz session for you to participate. So let's take a look. I kindly request you to go to this website, cquiz.de, and enter the code and join the game. So guys, we are gonna start it in couple of minutes. You can enroll yourself now, so make it quick. So it seems like some of you have joined the game. So let's start. Before starting the question, let me explain the rules for you. There are 10 MCQs in the game. For each MCQ, you'll get 20 seconds to answer the correct answer. After each question, the correct answer will display and a leaderboard will show up showing your scores against other players. So at the end, we will see who will win this fun game. So let's begin. Thank you. Sorry guys, something happened with the platform. You'll have to register again. I'll show you guys the quiz code in a minute. Sorry for the inconvenience, guys. Uh, some problem occurred with the platform. So get yourself enrolled with this code. So guys, the quiz is live. Questions are on the screen. You can start answering now. So seems like Plato is ruling the scoreboard. Let's move into the next question. So 5 questions down. Vidusha is leading the scoreboard. Danielka is in the second place and Danindu is in the third place. Let's keep it moving, guys. 5 more to go. So, okay, guys. One more question to go. Seems like you all got this question wrong. For your information, the answer for this question is Q. So keep that in mind and let's move on to the last question. Good luck. So with that, the quiz ends. Congratulations, Danielka, Danindu, Vidusha, and thank you everyone for participating in this quiz. So before moving to our next proceedings, let me tell you that we have hosting our registrations, team registrations tonight, and we'll share a post about that in your WhatsApp groups. So with that in mind, let's move forward. Over to you, Sarini.
Thank you, Sandaru, and heartiest congratulations to Danielka for winning the game. And we hope that you enjoyed the quiz. So we now have reached to the end of this session. In this awareness session, our hope was to simply provide you with the essential knowledge to participate in this exclusive competition. And we remind you that we, as the IEEE Student Branch of University of Sri Jayewardenepura, is ready to support you at any time in anything. And with that, to mark the official ending of today's session, I cordially invite Amandi Atukorala, the Secretary of IEEEXtreme 17.0 Programming Competition, to propose the vote of thanks. Amandi?
Thank you, Sayuni. Ladies and gentlemen, a brief but heartfelt thank you to Mr. Pasindu Wijesena for sharing their insights and expertise. To our attendees, your presence had made this gathering truly special. Thank you for your active participation. A big shout out to the organizing committee for their hard work and dedication in making this event success. Thanks to all contributors, sponsors, and volunteers for their valuable support. Let's carry the inspiration and connections gained today for our future endeavors. Thanks you all for being part of this memorable event. Wishing you a great evening. Thank you.
Thank you very much, Amandi. So, you may have heard the saying that time waits for no one. And here, we mark the end of the IEEE Extreme 17.0 Programming Competition Awareness Session. With the warm invitation for you all to use this valuable opportunity to take up the global coding challenge and shape your lives, we hope that many skilled programmers and talented intellectuals will emerge within this group of individuals who will take our future of the country. On a final note, there are 5 essentials for living a successful and fulfilled life. Never stop dreaming. Never stop believing. Never quit. Never stop trying. And never stop learning. I'm Sayuni Gamage. Thank you very much for joining us today and have a nice day.